Factoring completely means that you can factor more than once. Often it means you need to factor twice. Sometimes it means you have to factor multiple times. But for 2x squared plus 4x minus 8, the first type of factoring you want to look for is GCF. Is there a greatest common factor in the polynomial? In this case, the answer is yes. You could take out the 2 and you're left with x squared plus 2x minus 24. And then what you need to recognize or look for again is, can I factor what's left over? And you can. You have a trinomial there that can be factored with x plus 6, x minus 4. The trinomial to the right is very similar. The GCF this time is an x, and you're left with x squared plus 2x minus 3, and then factor that to 2x. Let's see, multiply to negative 3, add to positive 2. That'll be plus 3 and minus 1. And this could all be checked with distribution and FOIL and kind of reverse factoring. 3x squared minus 27 has a GCF. We could take out a 3. You're left with x squared minus 9, and what's left over is a dots. And so you got to remember to keep that GCF out front, but factor to the dots to x plus 3x minus 3. X to the fourth minus 16 does not have a greatest common factor, but it is a dots, so let's start there. You can factor it like a dots. Let's see, square root of x to the fourth is x squared plus minus, and square root of 16 is 4. And then look at those, x squared plus 4. Let's see, it's not a trinomial, it's not a GCF, it's not a dots, it can't be factored. But x squared minus 4, however, that is a difference of 2 squares because of the minus sign between, so that can be factored again to x plus 2x minus 2. And we have to bring down the x squared plus 4. So factoring completely means factoring more than once, sometimes twice, sometimes multiple times. You always want to start by looking for a GCF, but sometimes it could be a dots a couple of times.